This is a video about solving inequalities with variables on both sides. For the most part, solving an inequality with variables on both sides is just like solving an equation with variables on both sides. For example, if the inequality in number 1 were an equation, the first thing we would do would be we would distribute here and here on each side and then combine like terms on each side. So that's what we'll do first for the inequality as well. To start, I'll distribute 2 to the x minus 8, giving me 2x minus 16 plus 9. Keep my inequality sign the same, greater than or equal to. 3 times 4 is 12 minus 3x minus 4. Now that I've distributed, I'll combine like terms. So I have my negative 16, remember that negative sign goes with a 16, with a positive 9, which gives me 2x minus 7 is greater than or equal to, then I have a 12 with a negative 4, 8 minus 3x. Now, as I would in an equation, I'm going to move all my variables to the left side of the inequality and my numbers to the right. I always move my variables first to the left, so I'm going to add 3x on both sides, and that's going to give me 5x minus 7 is greater than or equal to 8. Then I'm going to add 7 on both sides, which is going to give me 5x is greater than or equal to 15. And last, I divide by 5 to isolate the variable. Since 5 is a positive number, I don't need to flip the sign. So my final answer is x is greater than or equal to 3. Now the last thing I have to do according to the directions is graph. So since it's a greater than or equal to, I'm going to shade in 3 with a hard circle or a closed circle. And since it's greater than, I'm going to shade to the right, remembering to shade in my arrowhead. And we're done. Now that you've seen how to solve and graph a normal inequality with variables on both sides, we'll take a look at 2 special cases. For both of them, we'll start the normal way. So for number 2, we're going to start by distributing 2 to x and 3. So we'll have 2x plus 6 is less than 5 plus 2x. Then I'll move all my variables to the left and my numbers to the right. So starting with the variables, I'll subtract 2x on both sides. And since there's 2x on both sides, they're going to cancel out on both sides, leaving me with just 6 is less than 5. Now, the thing about 6 is less than 5 is that that's definitely not true. 6 is not less than 5. That's false. So because this inequality is false and the variables canceled out, just like an equation that yielded a false equation after the variables cancel out, we're going to say that this has no solution. Absolutely no x, when you put it into that inequality, will yield a true inequality. Now, in order to graph the solution, I'm not going to tell you how to graph the solution to a no solution inequality. I would like you, in your notes, to graph what you think you would do for the solution if the answer is no solution on the number line. Next, we'll look at example 3. There's nothing to distribute in this one and no like terms to combine, so all I need to do is move all the variables to the left and the numbers to the right. So I'll start by moving the variables to the left, subtract x on both sides, and when I do that, my variables actually cancel, again because I have x and x on each side, leaving me with 5 is greater than or equal to 3. Now the difference is 5 is greater than or equal to 3 is definitely a true inequality. So this inequality will be true no matter what number you put in for x. Therefore, we say that all real numbers are solutions to this inequality. The last thing we have to do again is graph the solution. And once again, I'm not going to tell you how to graph all real numbers on the number line. Rather, I'd like you to write down what you think the graph of all real numbers would look like, and we'll talk about it in our next class. And that's it. You know what you need to know about solving inequalities with variables on both sides.